Hello guys, welcome back to my channel. We are continuing with the layout, right? We did pot wash area. Pot wash area doesn't have so many things. It's only this triple bowl sink and a 4-tire rack for storing the pots that you are washing in this area. One thing that we didn't do right here is the floor galley. The floor galley that you can see under there, we didn't do. But since we have several, there is another one here and another one. Since we have several, we will at some point do one, and it will cover for all the other galleys that are found in the layout. So today we are in the dishwash area. We are in the dishwash area, and as you can see, DW5, these are 4-tire racks. We are now again going to do 4-tire rack because we covered that in dry storage area. They are the same racks. The only thing that you might find different is the size, the length, yeah, and length of 4-tire racks. They range from 1 meter all the way up to say 2.3 meters. The depth is the same, 500. So today we are going to talk about the dishwash unit, you know, the dishwash itself plus the pre-rinsing and the run-out table. And what we are going to start with is the pre-rinse sink. Here I provided a single bowl sink, but we are going to do a double bowl. And if I might pull a photo of the arrangement of the dishwash area of the dishwash unit, this is how it looks. Here we have the pre-rinse sink, then the dishwasher, then the run-out table, right? And as you can see, the sink and also the table, they don't have legs. They have only 2 legs. There is no harm in putting 4 legs, but the profile of the sink and the table towards the side that will be next, or rather adjacent to the dishwasher, it has a profile such that you normally hook it on the dishwash machine, so that as you pre-rinse your dishes, you slide the crate through the sink into the dishwasher. And also once the dishwasher has finished its job, you slide again the crates with the dishes to the run-out table, right? And some run-out tables, especially what I will be providing, it has runners for storing the washed dishes for them to dry before you put them, you know, into the 4-tire rack and all that. So this is how my pre-rinse sink looks like. Yeah, this is the profile, how it goes. Like I have said, here is where you're going to hook it onto the dishwasher, and the size of the sink is 1500 by 750. There is this profile here is around 130, actually 140. And the size of the bowls is 500 by 400. The depth is 300. I didn't indicate here. It's supposed to be 300, and it has square legs of 40 by 40 and a 25 by 25 bracing. The 2 sides have bracing at a height of 200 millimeter from the ground to give clearance for the purposes of washing the floor. Then the front bracing is way up there so that it might not be an hindrance to the operator, right? So with that being said, let us go right into it. And at this point, allow me to say this. Most of these tutorials that I'm giving as far as this layout is concerned, they are majorly dealing with sheet metal, right? It might be a little bit boring for you because you might be looking to learn a lot in SolidWorks. Well, we are concentrating with sheet metal for now. Once we finish with that layout, we will start dealing with other things, gears. You know, we also got to, what do we call it? We design screws, or you can design screws, different components and all that, so that we may see how we work with these other functions as you can see them on my screen. Also surfaces and surface modeling and all that. We have dealt with sheet metal and weldments. We also will tackle direct editing and simulation. Yeah, and all these things, we will be dealing with them as time goes by. But as of now, bear with me, we finish with this layout and continue working on sheet metal. So, you go to the front plane and create new sketch. The new sketch, you take center rectangle from the origin and smart dimension. This is 1500 by 750. That is the overall size of the sink or the pre-rinse sink. Exit the sketch, hit spacebar, top plane, create reference plane. Reference plane, you offset it like I normally tell you. You can offset it by whatever value that you want. Then from the inserted plane, you create new sketch. Spacebar, normal, then center rectangle. Do not snap it at the middle as usual. Then we smart dimension from this line to the first sketch is 50 millimeter, and this line to this is 50 also. Then not 150 but 50, sorry. From this to the overall we put 135. Exit smart dimension at this line and at this line, you make them collinear. I was supposed to pick this line and this line, make them collinear, because ideally there will be no bend. It's just a bend that will be going on the downward side. So go to sheet metal, base flange, material. This thing is made of stainless steel 304 1.5 millimeter thick sheet. Click OK, and there you have your base flange. Hide this plane, create an edge flange. As you can see here, the height of this edge flange is 60 millimeter, right? 60 millimeter. So we create edge flange here, and condition, keep it blind. Size is 60 millimeter. Right click. Then we create a tab, a base flange on this face, and with you hit the tab, then you hit the face where you want to create your base flange, then choose corner rectangle, snap it at that point. We are going to give it some relations. This line and this edge, make them collinear. this line and this point. I'm holding the shift key to select both of them, make them coincident. Right, exit sketch, make sure you merge result so that this might be one continuous phase. Right, with that we create edge flange on this side, go into the upper direction, and on this side change direction. Yes, now it is at a degree of 150. As you can see, we are trying to create this edge flange here, and it is at a degree of 150. So 180 minus 150, you will have 30 millimeter, and the size, as you have seen, is 20 millimeter. The size of that edge flange is 20 mm. Right click. See, this bend is not going all the way to this side, because here is where you will be sliding your trays. Right, then create an edge flange on this side, go into that direction, then on no, before we create the edge flange, let us close this corner. So click corner, closed corner, bat type, then you choose this face, and automatically the matching face, it will choose itself. Click OK, and your matched corner is good. And create edge flange on that side, and another edge flange on this side. Then make it parallel to the face, and the face it should be parallel to is that one. Don't give it dimension, because we are going to create relations between the sketch of the edge flanges to the initial sketch, right? So don't worry about the size. Now come, choose that face and edit sketch. Choose this line and this line and make them collinear. Exit sketch. It will adjust itself accordingly, right? If you were to go to the second sketch, this sketch, and edit it and try to check the relationship between that line and this, you will find it is collinear, right? The initial sketch, the first sketch, always helps us to ensure that the scene, whatever you're trying to do, has the overall dimensions. So the edge flanges and all that, you won't be required to do a lot of measuring and all that, right? Now we go to closed corner. We close this corner, closed corner, keep it but this opening gap of 1.1 millimeter is good. Now we don't need this face, we don't need that face, so delete that face. I cleared everything, so we need this face, and matching face is this one. Right click, there you have your closed corner. Right, now here we have an edge flange perpendicular to this face, and the size of that edge flange, keep it and condition blind, size is 20 millimeter. That is good. Now here you don't need to do the edge flange of 15 millimeter going into this side, because this is the one that you normally hook on the dishwash machine. Right, so create edge flange going downwards of 50. Some people normally do it at 40, but for proportionality sake, 50 is always ideal. Then you create an edge flange again here of 15mm on the two sides, going to the inside. This avoids sharp edge and gives this edge flange some strength. 15mm. Right click. Well, our sink is really taking shape. Now create an edge flange at the back. Don't worry about the size, we will edit the sketch. I'm sure there is another way of making sure that these two lines are collinear. I'm used to this. Exit the sketch. Then create another edge flange, the upstand of the sink. Well, this upstand, which is 50mm. Well, I will, the next time I find myself in a functioning hotel, I will ask a chef why the profile of the dishwash pre-rinse sink or the run-out table, why they have this profile. What is the purpose of this? Because honestly, I don't know. Right. Something is not right here. Let me choose sketch 1 and I edit it. I create a line from here to here, and as we were saying, from this line to this line is 135 plus 15. I will explain that. Yes, that's good. Now, why I did that is because, as you can see, this is 135, then we have this 15. This line, this edge flange, we should make a relationship with this line, not the overall size of the sink. So we go ahead and edit this sketch, and we choose this line and this line, and to make them I think this card changes. Let me choose this edge flange and this edge flange and delete them and redo them. Right, that relationship there will give me some trouble trying to edit it. This line and this line, we make them collinear. No. I'm doing the wrong thing. I should edit base flange. Edit this line and this, delete this, then this line and this, I make them collinear. Yes. Then, now that is good. Now I go back to sketch 1. I create another line here to here. And I give it smart dimension from here to here, we make it 15 millimeter. Yeah, so that this line, I edit this sketch, this line and this line, I make them collinear. Yes. Yes, now our sink has taken shape. Then we do an edge flange here of the upstand and condition blind. 50 millimeter is the height, isn't it? Yeah, it is the height of that edge flange. Make it 50, that's okay. Then we do another edge flange. Right click, click on the edge flange, edit sketch, this line and the overall sketch line, make them collinear. Exit sketch, and that bend should be around 15 millimeter. Then bend going downwards and condition blind, size 10 millimeter. Yes, and our sink has taken shape, so I hide sketch number 1. Now as you can see, there won't be a lot of welding with this sink, right? The only welding that will be done will be right here, right on this edge. It is always a very clean sink when it is fabricated well by somebody who is experienced. You normally get a very clean pre-rinse sink. So we create the opening for the bowels. Created new sketch on this face, then center rectangle, and again center rectangle. Because it's a double bowl, we shall create relationship. This line, this line and this line, we make them collinear, we make them equal. Yes, this line and this line, we make them equal also. Now, I did not indicate the dimensions from this edge, but here you can give it 120. You don't need to leave a big space. You also want here to have a space that can almost fit a crate. This is 500 by 400. And between the two sinks, between the two bowls, I don't know whether this will work or I will be required to. No. Let me delete this. Yes, between this and this, make it 60, and from here to here, make it also 60 millimeter. Yeah, that looks pretty good. Go to feature, extrude and cut, link to thickness. Opening of the bowls has been made. So we create fillet, full fillet, constant size fillet, and the size 30 millimeter. Choose this edge here, that edge, and you choose this. It will highlight all the edges within that cutout. Then again here, you choose that, right click, your fillet is good. Now here we need to create new sketch, normal, and we need to create opening for the top, and this is center circle. The top is pillar type, the spray pillar type, what do we call it? 0.5. The opening should be slightly bigger. I told you the top is almost 20, dia 20. It's a standard size top. It's dia 20. This give it 50. And from the center to this edge should be at the center 60. Extrude and cut. Extrude and cut. Linked thickness. Click OK. Now the tab that we recommend to use in these is the exactly this is the tab that I'm talking about, and it's a mixer tab. It can give you hot water and cold water, and it has what do we call it? A pre-rinse tab, because you want to spray your dishes at pressure to remove all the remains of food, right? So you go ahead and save your work. We go to your folder, save it accordingly. 9 items are putting them under layout. I create a new folder, and this is DW, and in the DW DW additional area. From the DW I open, what's going on? How many folders do I have? DW, I already have DW. Can I delete this folder? I will delete it later. And from the DW I open and create new folder here, and this one I will call it pre-rinse. Sync. Then I open the folder and say part number 1, call it DW1 top. Now we are going to create legs. You don't necessarily have to use weldments, right? You can create a single leg, then you are going to assemble the legs. So the leg is 40 by 40 square tube. So create new part, click OK, top plane, sketch, center rectangle. From the origin, create relations between this line and this line, make them equal. This line and this, make them equal. Smart dimension, this is 40 mil. You can extrude this feature, extrude direction 1. What is the size? 830. If you had your grommet, it will come to 860. You don't want it solid, so you can shell from that face through to this face, and the thickness 1.5 millimeter or 1.2, depends with what you have in your stock. Go ahead and save it as part number 2, and call it DW1 legs. I will come and create a new part, top plane, sketch, center rectangle, smart dimension, this is 400. We are creating the bowl 400 by 500, right? Feature, extrude, the depth is 300. Click OK. Fillet at 30. You fillet this, choose all the corners, then at the bottom, not really. Fillet 30. This, choose all the corners, then I will choose these edges one by one. That and that, that and that. Yes. The other bowls, if you have been observant, they have been looking kind of funny because I've not been filleting down there. I'm shelling, and the thickness of the shell is 1.5 millimeter. Yeah, you have your bowl. You can't get a flat pattern from this unless you introduce create some bends, right? I want to create a new sketch here for the opening of the drainage, the center of the bowl. Smart dimension, this is 50 millimeter. It's a 2-inch bottle top, so the dia is 50. You go to feature, extrude and cut, linked thickness again. You want the opening is good. Go ahead and save this as part number 3, which is DW1 bowl. Now we start our assembly. File a new assembly. The first part to bring in is the top. Second part, you can bring in the bowl if you want. Insert component, leg. I saw somebody doing what? I don't know, because I need 4 and I don't want to keep bringing in 1. How do I copy this? Somebody who knows how to copy this so that I may have 4 components, I really would appreciate. Met, and the first met is this face to this edge. I want to make sure that I choose the correct edge. Right click, then this face to which face? To this face. Then this face right here to this face. Yeah. No, I don't want to mirror, because if I mirror this leg and there is 15 millimeter bend here, I will be having some issues. So that is why I was asking how to copy this, that I may have 4 legs, but hey, let me do it manually. This face to this face, then the bottom to the bottom, mating them, and this face to this face here. Yes, that leg is good. It's not much in this thing. I'm bringing in again another leg. I don't like this, but what do I do? Alternatively, you can do, actually let us delete this and evaluate, measure from here to here. Normal distance is 586. I don't know whether we are going to get it right, but I think we are going to get it right. So what we are going to do is linear component. That's the direction. Change the direction so that the arrow may face that side. This is 2. Numbers size is 582. Sorry, 582. Something that we can always change. This leg and this leg. 582 minus 40. Sorry, minus 40. I want to see whether it will flash. Ideally, it should flash with plus 5 millimeter. 5 is a lot. Plus 2 minus 3. Yeah, that looks nice. Can leave it at that. Yes, your sink has taken shape. So this part, actually you need to give it a like 20 millimeter gap. From here I need to edit some mate. That mate here, I need to edit it, and instead of choosing, let me clear this, and I choose distance, and this distance I can make it 20 millimeter. From this face and this face, you want there to be a gap for you to be able to hook the sink onto the dishwash machine, right? Yeah, there should be a gap that is sufficient. Alternatively, it is not very necessary to have these legs unless the length of the sink is big and you are scared about the weight. And because ours is a double bowl, that's why we incorporated these legs. Okay, so I'm bringing in the bowl and I'm going to mate it, and like I normally tell you, bowl, mating bowl, you don't need to put so many relationships. You just choose the midpoint of the bowl and the midpoint of the cutout, and that will be good. I know degrees of freedom are about 3, but this is just for illustration. If you want, we do linear component. Now it might not be very precise. We'll start doing trial and error, whereas we can bring in another bowl and mate it just like we did with the previous one. This to the midpoint of that. Yes, and the sink is taking good shape. Let us evaluate and see what size of the bracing we require. From that face to this face, 544, and from this face to this face is normal distance is 1385. Let me note it somewhere lest I forget. 1385 and 504. So let us go ahead and create a new component, new part. This time round we go for the right plane, new sketch, center rectangle, I don't want to shell, you know, it is always good sometimes once you do one thing, you do something different to the other. That is 25 by 25, and between this and this make it 1.5. Exit sketch this line and this line, make them equal. Yes, if you want you can give it a thin radius fillet of 1.2 millimeter, because a square tube is not always 100% perfect. Mid plane size of this is 1385. This is the long bracing. Okay, as I was saying, it is not always at 90. Even the legs we should have filleted, and the fillet is say 1 millimeter. That shows all the four corners. Yes, square tubes always have a small fillet. Save as part number 4, DW1 long bracing. Then we create new part, click OK, front plane, new sketch, center rectangle, create relationship between this and this, they should be equal. Then you offset it, offset by 1.2, 1.2, choose this reverse direction, that's good. The overall size, a smart dimension, the overall size is 25. Yeah, so the different ways that you can create the same thing. And condition mid plane size is 544. 544. That's good. We can create a fillet. You can also fillet the sketch if you want 1 millimeter. Choose this. That's good. Go ahead and save it as part number 5. And this is the short bracing. DW1 short bracing. Go back to the assembly. Insert component, long and short bracing, 1 and 2. Now we need to met. The first met we are going to do is width met, advanced met. We choose width between this face and this face. Tab selection is that and that. Realize the other leg was the size of the leg is 40 millimeter, that face, and which face? This face. No. We are not supposed to do width. Clear. We go to simple standard mate and coincident. We take this face and mate it with this face. That's good. Then from there we take distance, and we said clearance is 200 from this face to the bottom of the leg. Should have a ground clearance of 200 millimeter. That's good. I shouldn't have exited, but hey. This face to this. I keep saying you can always try some new things. Send out the profile. That profile, I don't know. And this profile, no, it won't work. Let me go for with this face and this face, and that face. Good. That's perfect. Now, here is where all of us need to be learning. As I'm also showing these things, I need also to be learning. So if you know how, instead of choosing one component, yet it's one and the same thing. No, this we can avoid by let me collapse this. Then I go for the long bracing, then I choose the right plane and do mirror components, a component to mirror. That's good. Now I will insert the long bracing, then I do mating, coincident this to that face. Then I go to advancement with this face, then this face, and up here this face. That's good. Then I go to distance, and I like 200 from the top, from this to this. Yes, that's good. Exit. So that's about that. Our sink is done. In fact, if there is anything that is remaining, is to insert the grommets. I have the grommets, but I'm not going to design grommets. So get your grommets from your supplier, you insert them here, and your pre-rinse sink is good to go. Go to the site. The taps and the drainage, they are normally done at the site, and your whole setup looks nice. Let's give it smooth edge. There you go. There is your double bowl pre-rinse sink. So go ahead and save it as DW1 pre-rinse sink. Yeah. Thanks so much for your time, guys. Let us meet in our next tutorial, and we'll be talking about the runout table.